All right, our subject today is respiratory protection. Like I said, this subject is one that that some of you may have this exposure, some of you may be concerned about it, or some of you may say, you know, the guys out in the shop have a box of these 2-string dust masks. Is that a respirator? Do I have to do anything about that? Am I going to get into trouble with OSHA? And more importantly, are our people safe? Are people going to get themselves into problems breathing chemicals or particulates or whatever it may be? And so you come here maybe out of curiosity, what about this or that? Well, this is a pretty big exposure that we may have, pun intended, on that. This is something that if we use a respirator improperly, it can be worse than not using it at all. And so we've got to know what the risks are, and we've got to handle those appropriately. There are OSHA requirements and OSHA respiratory protection standard around this, which is great and important to comply and all, but at the end of the day, it really comes down to keeping our people healthy. And if we use the wrong gear, if we use it improperly, that could be worse than not using it at all. So let's dive in and talk about respirators. The majority, over 70% of facilities that use respirators didn't use any sort of air testing or sampling to determine whether they use respirators or not. That's something that's a bit concerning because we don't know how much we're exposed to, what the materials are, and we may be just throwing a respirator at it. We go to the auto body shop and say, hey, I need a respirator, and they say, well, here's one. And you ask the guy behind the counter who's worked there all of 2 days, is this one okay for what we're doing? Sure. It's the highest priced one on the counter, so yeah, go ahead and use that one. Here's a few other statistics that are a little alarming. 42% of respirator users didn't have any sort of training. That's one of the reasons we're doing this class today, is to provide some basic levels of training. However, as an employer, you have the responsibility to train on the specific use and the types of tasks that the people are using these respirators for needs to be site specific. This is a basic training that gives you an overview, and then you're responsible to look at the site specific information. 40% didn't provide the required respirator training or fit testing. What's fit testing? We'll talk about that, but ask yourself, have we done that? 50% did not provide the required assessment of employees for medical fitness. Have your people had a medical qualification to wear a respirator? Oh, wow. You're saying we got a fit test, we got to medically qualify these people? What the heck? This is a big deal, and it is a big deal. So, and everybody ought to have one of these. This way you get all of the nicotine at once. So our training goals today, number one, I want to talk you out of using respirators if you don't need those, unless you absolutely have to have them. Don't use respirators. It puts you at risk. Okay. We want to talk about the OSHA requirements under the Respiratory Protection Standard, and but like I said, the most important thing is to keep your people healthy and keep them safe in the jobs that they do, particularly when they're working around chemicals. All right. OSHA requires training as part of the Respiratory Protection Standard. You also need to know how to properly fit a respirator to your face. The weakest link in a respiratory protection system is the seal that respirator makes between it and your face. Your face is the weak link. If we don't know how to get a good seal, then that puts us at risk. Limitations. A respirator will only protect you to a certain point. It will only protect you from certain contaminants. This respirator here is only for particulates. If there's a gas in the air that is toxic to me and I'm wearing this respirator, guess what? I'm getting the full dose of that gas. This respirator won't do anything except protect me from particulates. You also need to know how to inspect, clean, maintain, and store your respirator. You need to be able to check seals, do a positive and negative pressure fit check. We'll talk about that. And be able to maintain the stuff appropriately. You should be able to take that respirator apart, clean it, and put it back together and not have any extra parts left over. That's an important skill that you need to take on if you're a respirator user. And if you're the employer, you need to ensure that all the employees know how to do that as well. Okay, so like I said, this is a very general class, and it's not focused on those who are, and it's not intended to provide training specific to the types of risks that you have. We might give some examples, but you need to talk to employees about their own specific risks. All right, emergency preparedness is also a part of this. So we ask ourselves, why respirators? We use respirators when we are overexposed to a contaminant and we haven't been able to engineer out that exposure. So our primary responsibility is to use ventilation or some other engineering control to separate us from the chemical exposure. If that is impossible, and that's a pretty high hurdle to jump, and when we say impossible, then we can go to respiratory protection. Now, you think of the example of firefighters down in Bryan Head. They've had over I think over 1,000 firefighters working that fire at any one time. That's a lot of people, and they may use respiratory protection. Wildland's a little bit different. Maybe that's not the best example, but if we're doing structure fires, we have respiratory protection. You say, well, you got to engineer that out. Well, it's pretty tough to do in an emergency situation if I've got a house burning, and so it's standard procedure for those structure firefighters to wear respiratory protection. If we're over the limit, or we don't know what the material is, we don't know what those exposures are going to be, then we may use respiratory protection to protect us. Okay. Whether we're using it in an emergency or regular use, there should be some procedures about that. We'll talk about each one of those. Oh, and voluntary use. There are situations where we can allow an employee to voluntarily use a respirator because either their doctor has said they need to wear a respirator, or just for a comfort factor. Hey, you know what? I don't like it when I sweep the shop out and I get done and I go and blow my nose and there's black stuff in there. I want to wear a dust mask to keep that stuff out of my respiratory system. Well, we've got a decision to make if somebody comes and asks for that. We can allow voluntary use, but we need to plan ahead for doing that. Uh-oh. All right. Sorry, I clicked twice. So how do we know if we're overexposed? A couple of different ways. One is process knowledge. How do we go about doing this task, and how much stuff is this going to put in the air? The other thing is to physically go out and test that. And we offer a limited amount of testing. So if you've got kind of a tricky situation that's hard to tell what our exposure is, talk to me and we'll help you out with that testing. So what do we have to evaluate? We kind of look at the different types of exposures depending on the state of matter, solid, liquid, or gas. These can all be respiratory hazards, and so we have to look at each one of those and identify where the risks are coming from for our employees. Okay, chemicals can get into our bodies in multiple different ways: injection, ingestion, absorption, and inhalation. Inhalation is the primary route that we're really concerned about. Yeah, I worry if I spill battery acid on my hand because it hurts and it burns and it could disfigure my body. However, if I breathe a toxic chemical into my lungs, that gets straight to my bloodstream and it can kill me. So the respiratory route of chemical exposure is the primary one that we're always concerned about. The others are important, and we need to address those. But respiratory route gets right to you, gets right to your bloodstream, and can have profound, almost immediate, in many cases, immediate effects on our body. That's why respiratory protection is so important. So just think about that. What can hurt you? Solids, liquids, and gas. Each of these have chemicals that can be lethal to us or cause us to be unhealthy. Oxygen deficiency is also an important thing as we talk about confined space entry. That's one of the major concerns that we have going into a vault or other confined space is have something consumed or displace the oxygen that's there. So how do we know that there's enough? And just a little fast forward on that, if I'm using an air purifying respirator in an environment where there isn't enough oxygen, I'm still going to die. It's not going to provide oxygen. So that's a little fast forward. So just think about this. Liquid hazards. Whoops, excuse me. I jumped ahead. Let's talk about solid hazards. I'm looking at the next screen ahead. Solid hazards. Dusts and fibers and fumes are different types of solid particles. So dusts are generally those big things. And if you're interested in the subject, we just did. I believe that was last month, maybe 2 months ago, a presentation on silica. That's a form of, it's basically a mineral that is in sand. It's crystalline silica, and it can be in concrete. The rock and aggregate that we have inside of concrete, so we go out and solve that. This gets up in the air, can cause silicosis. It's a lethal, progressive type of lung disease that we can get from exposure to that. And it's not just cutting; it could be just moving material. If you've got a rock crusher or you're out loading trucks at the gravel pit, that can be a significant exposure. Fibers are like asbestos and fiberglass. These are things, particularly with asbestos, that can stick in our lungs and do damage for decades until they contribute to us getting lung cancer, long-term lung disease. This is a big deal. Others are less hazardous to us, like fiberglass insulation. Even though we don't want to breathe that into our lungs, the difference between asbestos and fiberglass insulation is fiberglass is soluble in lung juice. Our body can purge that material, whereas asbestos just sits there and does damage for decades until it causes cancer or other diseases. Fumes. What's the difference between a dust and a fume? And it's really size. People talk about gas fumes coming out of their tank when they're filling up their car. Well, the reality is those are not fumes, those are vapors. A fume is a really, really small solid particle. So the example would be welding fumes. If I'm welding on a piece of metal, my goal is to melt the metal and fuse that together. But in doing so, I put a ton of energy onto that metal in the form of an electric arc. And in doing that, I vaporize some of the metal that's there. It kind of becomes a gas instantaneously, and as it comes away from that arc, it condenses down into a really, really small solid particle. And here's as we talk about hazards to our body, here's something that we should remember. The smaller the particle, the greater the hazard to me. What does that mean? Well, that means the small particles get into the deepest reaches of my lungs and can cause significantly more damage than a large particle. Remember going back to sweeping the shop and I blow my nose and I've got black stuff in there? Well, what that's telling me is your body's doing a pretty good job of capturing dusts, those big particles that are there. Does that mean some of the stuff gets down into your lungs? Yeah, it does. But our body, our sinuses, and our trachea, that system is set up to eliminate these big particles. When they get really small, it's hard for our body to stop those. They get to the deep reaches of our lungs, and so those metals that have become a fume from our welding actually get to the deep reaches of our lungs and can enter the bloodstream and make us sick. So if you've ever, if any of you have ever cut or welded on galvanized steel, you may have gotten sick if you didn't have good ventilation or respiratory protection. It's called metal fume fever. Zinc and manganese that are in galvanized the galvanized coating get into our respiratory system, hit our bloodstream, and cause some really nasty illnesses. It's like you got the flu. It's called metal fume fever. You've got a fever and you feel sick as a dog. It is really nasty stuff. Okay. All right. So solids. Let's talk about liquids. Same thing, we won't go into a lot of detail on this, but the smaller the particle, the greater the hazard. So mists are big particles. Aerosols are a lot smaller particles. Aerosols can reach the deep reaches of our lungs, and this is really how sometimes we can get sick. Somebody sneezes, they're sick, and they sneeze, and they let out they let out these really small droplet particles that may contain viruses or other types of pathogens. And we breathe those in, it gets to the deep reaches of our lungs, and then we get sick. Okay, but it can be a chemical exposure as well. Gases are free to go wherever they want. They float around, and they can enter our respiratory system, big, dangerous. Okay, all right, so now we've talked about what some of the hazards are, and you should be aware of what you're dealing with at work. Have a list of those hazards and think about what controls do we have in place to reduce that exposure as much as possible. All right. If you determine that we need to have that we need to wear respirators, then you need to have a written respiratory protection program. That is something that is specified in the OSHA standard. And it tells you how to select the appropriate respirators, how to medically qualify a fit test, and have procedures on how your employees should use these respirators. What are the rules that we're going to follow when it pertains to respirators? Don't just go and buy a box of dust masks and say this is going to be okay. How often do we change out the filters or the cartridges that we have on these respirators? There should be a policy or procedure on doing that. How do you clean? How do you store? Who is allowed to wear respirators? All this should be in our written program. This is an OSHA requirement. If we have exposures that require us to use an airline or a supplied air respirator or an SCBA, we need to have procedures around emergencies. How do I ensure that I've got safe air going into the respirator? Okay. All right, next one. We need to designate a program administrator. Who is the responsible person? We always call them the designated felon. If we mess up, who's the person that's going to be the one holding the bag at the end of the day? So we designate this person as the designated or as the program administrator, and so they administer the program. They say how, when, where, why, what, all of those things about that, and they evaluate the program to make sure it's working. All right. How do we select the right respirator? I've already got you nervous here by saying you can't use this respirator for gases. How do I make sure that I've got the right respirator? Well, number one, it needs to be a NIOSH approved respirator. So it'll say NIOSH on there. It'll have a number. That's the National Institute of Occupational Safety and Health. We need to make sure it's appropriate for the contaminants and the conditions that we're using. How do I determine if it's appropriate? Well, you can do a couple of different things. One, you can talk to the manufacturer. Hey, here's the process that we're doing. What's the right manufacturer for this? And generally manufacturers the reps that sell respiratory protection are pretty sharp. They know their stuff pretty well, so they get the right thing, because if they don't, somebody's health's on the line. So they don't mess around and just take somebody off the street and have them go hawk respirators. The other option that you have is to give me a call. I'm happy to help out in looking at your process and selecting the appropriate respiratory protection for that. You need to have enough different sizes and models to fit everybody. If you take a look around a room of 100 people, you'll realize that there are 100 different shapes and configuration of faces. Even though we may all look kind of similar, when you start looking at fine details and trying to make a respirator that fits everybody, it's pretty tough. So you need to have some options for people. So in selecting what respirators we're going to use, here's some big considerations. If I don't have enough oxygen, if there's a potential for oxygen deficiency in the work I'm doing, I can't use an air purifying respirator. I've got to use one that supplies air to me. If I'm working in IDLH atmosphere, immediately dangerous to life and health, this is a concentration where I can be overcome, be killed, or not able to get out of a situation, get out of the room that I'm in, then I can't wear an air purifying respirator again. So we need to have procedures for that, specific to that, and have backup people there. The other thing is emergency use. There are some places where there is a potential that we have an emergency release, and we've got to have some protection as we get out. Talked to a guy some years ago. He was in one of my classes. He worked out at MagCorp, big company out in the West Desert in Tooele County, and he said the area where he worked, they would have regular chlorine releases. There'd be a cloud of chlorine, and those of you that have worked around gas chlorine know it's nasty stuff. And the IDLH, immediately dangerous to life and health, concentration is 10 parts per million. It's really easy to get 10 parts per million. So these guys would have to wear on their belt an emergency respirator, so an escape respirator. So if the horn blew, that meant there was a chlorine release. Their job was to quickly don their respirator and get the heck out of the building. Kind of scary. We ought to all be glad we work where we do, that we don't have to have an emergency respirator on our hip. Okay, then we select the type of respirator that we're going to use. There are two types of coverings, a tight-fitting covering and a loose-fitting covering. Tight-fitting relies on the seal of our face to provide protection. So here are the different types. I haven't seen a quarter mask for a long time. I'm really not sure whether those are still even manufactured. But generally, we'll see these half masks, and the full face piece are the most common type of elastomeric respirator that we have. And then we have these emergency ones where you pretty much put a clip on your nose and breathe through this cartridge as you're getting the heck out of Dodge if there's a problem in the facility. A loose-fitting covering is just what it says. It doesn't fit tight to our skin. It doesn't have that rubberized seal. It actually has kind of a Tyvek type material that just shrouds most of the time under our chin. It may be a full helmet with a hood. Sometimes it can be an entire suit. And the principle behind these is we have pressurized air coming into the system that forces air out and doesn't allow contaminants to come in. Gives us a little better level of protection, and definitely a lot better level of comfort when we're using this type of respirator. Okay, so we decide what type we're going to use, and then we say which overall type we have. We have air purifying and supplied air. We talked about this a little bit. An air purifying respirator could be like this one. It has some cartridges on here. This is actually a particulate cartridge, and so I can use this. Say I'm out working in a dusty environment. I put this respirator on, I breathe in, create negative pressure, and it comes through this filter. This filter looks an awful lot like, if you look there, looks an awful lot like your shop vac filter or the filter on your air cleaner on your lawnmower, because that's exactly what it is basically a folded paper filter. It takes particulates out. But it does it in an air purifying manner. So I'm breathing the air that I'm standing in. If there's nasty stuff in that air that this doesn't take out, it's still getting in. So it's just purifying the air that I'm breathing. And it can be a physical method like this, or it can be a mechanical or a chemical method like this respirator, where there's a cartridge, and inside of there are chemical means that it will react with the material or sequester the material so it doesn't come through. And then the other option is a supplied air respirator. Can't see what I'm doing here. This is a self-contained breathing apparatus. It has a tank that has high pressure air, has a face piece just the same, and we hook up to a regulator to reduce the pressure, and it provides us clean air that we know is safe. This obviously gives you a higher level of protection than an air purifying respirator. There are some challenges to that. I can only carry so much air on my back. If I'm getting that supplied air through a hose, my hose can only be so long to be able to do the job. So, and it can be unwieldy to drag a hose. It can be unwieldy to wear a tank. So we only use these in situations where we have to. All right. We covered that. Wow, I jumped ahead. I got all that stuff done. I'm amazing. All right, once again, this is a negative pressure respirator. So I take a breath, it creates negative pressure in my mask, and it draws air through those filters. Now the filters work, they've been tested. NIOSH tests all these things, and they do a great job. What's the problem with a negative pressure respirator? If I have any leaks, if I've got a leak in the seal around my face, and I create a negative pressure, the air is going to take the path of least resistance to get in there. Well, I'm here to tell you that if it's got to go through this cartridge, there's a lot of resistance in going through there. It's going to come in through the leak and not through the cartridge, or not completely through the cartridge. So that puts us at risk. So that negative pressure respirator is inherently less safe than a positive pressure respirator. So this is a pressurized system where we put some pressure on the mask. If I've got this mask on and it has a little bit of pressure on it, and I have a leak, which direction is the air going to go? It's going to leak out instead of in with the contaminants. That's a much safer system than a negative pressure respirator. All right. You have a powered air purifying respirator, and what that does, I don't have an example here today, but you have a cartridge and you hook it onto a system. A lot of times you'll have a belt-mounted pack that has a battery and a fan, and you hook these respirator cartridges on it, and it draws air in through the cartridges and then provides you with that air. A lot of times these are coupled. They can be a loose-fitting or tight-fitting system, but a lot of times they're loose-fitting, and it'll blow that clean air into me and provide me a safer form of respirator. That is better than just a straight-up respirator. And box yet, but remember that. All right. How about these? What about this dust mask, or as OSHA calls them, a filtering face piece? So with this, the whole face piece is your respirator, and these have two straps. What about that respirator? What about that? Well, you ask yourself, is this a respirator? And the answer is yes. This is a respirator. Meets the requirements under OSHA. There are also or what, this has two straps. What if you have one that only has one strap on it? That's how the manufacturer intended it. Throw it away, because it's not going to give you any protection. Those are just really very, very simple things. They're not certified, and they're not going to protect you. This is a respirator. It will protect you. Don't cut one of the straps off because it's annoying. This relies on both of those straps to get a proper seal. Is this going to give you a better level of protection than this? No. Obviously, this is for nuisance contamination and Ebola. This is the respirator that the CDC tells us to use if you're working with Ebola patients or other patients that have some nasty stuff, nasty diseases. Kind of a little scary to me, but anyway, they've tested them. All right. So, are you telling me that this may make us have to have a written respiratory protection program and fit testing and medical qualification, all of that? The answer is yes. Okay. All right. Two different types of air supplied air respirators: an airline respirator or a self-contained breathing apparatus, or an SCBA, where we pack our air in a tank. All right. There are also those escape respirators. Here's an example of one. With these, you're supposed to do what your mom always told you not to do. You take a plastic bag, you pull the plastic bag over your head. Okay, make sure you turn the valve on first. Turn the valve on, pull the plastic bag over your head, and then run like crazy. You know, when I was a kid and did that, my mom thought I was kind of dumb. And yet, in a situation where we've got a chlorine release, this is a potential respirator that we could use for an emergency situation. All right, we already talked about the ideal age. I got this slide out of order, but that's immediately dangerous to life and health. How much of this chemical does it take to kill me or to incapacitate me? That's a pretty important number. I can't use an air purifying respirator in an IDLH concentration. I have to have a supplied air respirator for that. Okay. Oh, and in addition, if I don't know what a material is, say you're a firefighter or hazmat tech, and you're going into a scenario where you don't have any idea what the material is that you're working with, we don't wear an air purifying respirator because we have to select the appropriate cartridge for that chemical. Whether it's particulate or whether it's another cartridge, I've got to select for that material. If I don't know what it is, I can't select for it. So I'm going to use a supplied air respirator for that. Okay. So for IDLH atmospheres, we're going to use an SCBA or an airline respirator coupled with a 5-minute escape bottle. What that means is, and for my SCBA, I need to have at least 30 minutes of air. So when you look at your specifications for SCBA, you've got to have at least 30 minutes. And we can use an airline respirator, but I have to have a 5-minute escape bottle. So if I'm in an IDLH atmosphere and my air stops running, I need to be able to turn on that valve and allow this air to flow as I'm getting the heck out of Dodge. Okay. All oxygen deficient atmospheres are IDLH. That means less than 19.5% oxygen and specifically less than 16%. But from an OSHA standpoint, anything under 19.5% is oxygen deficient, and we would have to wear a supplied air respirator. And once again, like I said, unknowns will put us into IDLH. Okay. So what kind of air do I have in my tank? Well, it needs to be certified grade D breathing air. Can I just hook up to implant air for my air hose and breathe that? And the answer is no. It has to go through a process to ensure that it's good quality air, that it has enough oxygen, that it doesn't have contaminants that could cause me to become ill. And so it needs to be between 19.5 and 23.5% oxygen. So as we talk about confined space entry, those are important numbers. That's the windows of between oxygen deficient and oxygen enriched atmospheres. That's where it's safe. Lack of noticeable odor, we have to have carbon monoxide less than 10 parts per million and less than 1,000 parts per million of carbon dioxide. And also hydrocarbons less than 5. I didn't have that one on there. Where'd that go? Less than 5 milligrams per cubic meter of hydrocarbons. So talking oil, if you have an oiled compressor system, that needs to be filtered out so we're not breathing that oil. That can be bad on our lungs. You get enough in there, we fail. All right. So compressors need to be set up to take this bad stuff out. All right. So let's talk about the assigned protection factor. Each respirator has a factor that says it will protect you up to a certain number of times the exposure limit that OSHA or the ACGIH has put out there. So with a half mask, this will protect you up to 10 times the PEL as long as I don't go over the IDLH. A full face piece air purifying respirator will take me up to 50 times. Well, you say that sounds pretty good. Well, let's take a look. If we go down to a full face piece pressure demand SCBA, it takes me up to a protection factor of 10,000 times that exposure limit. That's pretty huge, and the difference is incredible. So if I'm going into an IDLH atmosphere, I definitely want that supplied air respirator. Okay? So if we take the exposure limit, times it by the assigned protection factor, that tells me the maximum use concentration. But once again, with an air purifying respirator, I can't go over. I cannot go over the IDLH concentration. How long do these cartridges last? There's a chemical reaction or sequestration that's going on inside of there, or if it's particulate, it's filling up. How long will they last? Well, we need to think about that, and that needs to be part of our program. Now, for particulates, here's a particulate respirator, and that other one has it on too, but I don't want to confuse things. How long does this work? This filter gets better and better. It's more efficient the longer we use it. But what's the problem? It starts to restrict our breathing. And under OSHA, as soon as we feel restriction in our breathing, then we should throw this thing away and put another one on. So for particulates, it's really the user experience. I can feel resistance when I breathe through this thing, so I'm throwing it away. Okay? For a cartridge, this has chemical reagents in there, and it's only going to last so long when it's exposed to that chemical. How do I know it's not too long? When's the stuff going to come through? It used to be that OSHA said when you can taste or smell the chemical, it's okay. Then it's time to change it out. Well, that's not good, because some chemicals you can't taste or smell. And even if it is, once I can taste and smell it, I'm getting exposed to this stuff. So, a couple of different options. One is to have an end of service life indicator. So many times these are color changed. So on this picture that we have on the slide, it shows that the little center area is either brown or orange. When it changes to brown, you need to throw it away. If it's orange, it's still good. Okay? These are not available for everything. I wish they were. That would make it really easy. One thing you got to remember on this, though, is if I've got this thing on my respirator, how do I tell whether it's changed colors or not? It's not good to take your respirator off and go, oh, I guess it's already changed, and now I'm double exposed. In these areas, if you're using these, you got to have some mirrors around so you can check your respirator or check your cartridge and make sure it's okay. In the absence of an end of service life indicator, we need to calculate a change out schedule. Manufacturers can help with this. They have some software programs that will help, or you can do it yourself. My experience with most of our members is that they only rarely use a respirator. And so they may have an air purifying respirator and they use it once a month because we have one nasty process. We're dealing with chlorine, or we're dealing with fluoride. That's a common one that I see. We're fluoridating our water, and when we're putting this nasty stuff into a tank, we're pumping it out, and so we wear a respirator for 15 minutes. How long are these good for? My recommendation is if it's just infrequent use, change them out once a month. Put a date on them as soon as you take it out of the package. Now they do need to stay sealed because this thing's working all the time. But once you open it up, put a date on it, and I wouldn't go beyond a month. Now, if you're using it more than just infrequent, then you want to calculate, because it depends on how much you're exposed to and the type of conditions under which you're exposed to it. So if you're going to calculate this, give me a call. Let's talk this out, and let's put together a plan. All right, I think I've covered all of that stuff, at least briefly. So when we start talking particulate respirators, you've probably heard of the N95. So this is one of those filtering face piece respirators. It's the N95. What the heck does N95 mean? Well, 95 means that it's taking out 95% of the particulates above a certain particulate, a certain diameter, which is a third of a micron or micrometer. And so that's taking 95% out. Does that mean 5% is getting through? Yeah, that's exactly what it means. We also have a 99 and a 95. 99 means it's taking out 99%. Or did I say? Yeah, 99 and a 100. The P100, or the 100 level particulate respirator, will take out 99.97% of particles above that size. What the heck does that mean? Well, that means it's taking out, we used to call those a HEPA filter or HEPA filter, and that's taken out the majority of those bad things. You can wear a 100 level particulate respirator when dealing with fumes, those really small particles. You cannot wear an N95 or an N1 or an N99 with that same thing. What does the N, P, and R mean on these? National Public Radio. No, it means the amount of oil that's in the atmosphere. You may work in a manufacturing plant where they have air, a lot of air tools being used that have, and the air is oiled to make sure the tools work right and the compressors work okay. If there's air in the atmosphere, you want to be using a P-rated filter. If there's just a little bit of oil, you can go to an R, and if there's not any oil in the atmosphere, then you can use an N. Okay. I'm giving you a lot of stuff fast, so if you got questions, please hit me with those. Covered that, and if it's a bigger question, give me a call and let's work on a program. Medical evaluation. You're required under OSHA to medically qualify all employees who are required to wear a respirator. That means they need to go to a physician or licensed healthcare practitioner. Okay, we'll just call them the doc. But it could be a nurse, it could be anybody who's licensed to do this kind of work. It's up to them to decide what those criteria are to wear a respirator, but you should share information with them. Let them know what type of work you're going to be doing, what the chemicals of concern are. There's also a questionnaire, so it's Appendix C of the OSHA standard, and you need to provide that to the employee. You shouldn't see their answers to that questionnaire. That's part of the program, is that you're not supposed to see that. So if you're going to collect those and send those into the doc, make sure that you put those in a sealed envelope, and so they can, you know, if you're going to collect all of those and then send them all together with the doc. Make sure they're in a sealed envelope. So then the doc can look at it. What do I get when the doc gets done, or before I get to that point? So do they need to go see the doctor? It's really up to the doctor. The way the standard reads, you can have the doc look at the questionnaire. If they don't see any need to have a follow-up visit, then that's okay. My experience now is that the docs pretty much want to see everybody, whether that's just maximizing profits or minimizing risk. I don't know. It's probably a combination of both of those things. In most cases, the docs want to see them. You can use outside resources if you've got a bunch of people, you don't want to go to a clinic. They're mobile, and this could work for fire departments. But there are companies that will go to your site and do all of your fit testing and your medical qualification at one time. There are certain answers on the questionnaire that if you answer yes, one of which is, do you smoke, you're going to have a follow-up exam. Now that could be something as simple as a pulmonary function test or a chest x-ray, but there is potentially some significant cost that goes along with this. In most cases, these qualifications these medical qualifications are about $100 or even more. All right, what will the doc tell you as an employer? You will just get an evaluation from the doc that says this person may or may not wear a respirator. Pretty simple. As an employee, the doc will talk to you about your health and the risks that you have. But as an employee, you don't have to be worried that your employer is going to get information. Oh, this guy's got asthma, or this guy has some other issue that could affect his ability to do this. The doc's going to go out on a limb and say this person is or is not qualified to wear a respirator. All right, once we've done our medical qualification, we need to do a fit test. What is a fit test? Well, remember we talked that the sealing surface is the weakest link in the whole respirator. How this fits up against my face can determine whether I get exposed or not. Okay? So we need to do a fit test that determines whether I'm getting a good seal. We do that in a couple of different ways, and these are following OSHA protocols. One is a qualitative, the other is a quantitative fit test. If we have a fit factor under 100, then we're going to be using a qualitative fit test. What does that mean? It's just a pass or fail. If I have that higher level of protection, an SCBA airline respirator or something like that, I need to use a quantitative fit test. That means we hook you up to a machine and test the inside versus the outside air. All right. So let's see. So how do we do that? There are a few different types of fit tests that we do. I was going to put on my SpongeBob SquarePants. There we go. You put that little hood on, depending on what you're doing, and we're going to put contaminant in there. There are various different protocols. One's saccharin, the other one is Bitrex. There's irritant smoke, and this is an irritant smoke kit here. You have a little glass ampule, you break the ends off, and you start squeezing air through it, and it will let this smoke out. It's called stannous chloride. It's nasty stuff. It'll make you cough or gag if you get just a little bit going into your respiratory system. Not super toxic. It just has this effect of making you cough, making you not want to have this stuff around. Well, your air purifying respirator with particulate filter on there will filter this stuff out as long as you've got a good seal. So this is a good way to test somebody's fit. If I'm wearing this and I've got a good seal, I'm not going to cough or gag. If I don't have a good seal, it's going to look something like this. Maybe. I don't know if that audio is coming through. All right. So there'll be he might cough and gag, and then you reset you re-don the respirator and try again to make a good seal. This is part of the learning process, but it's also a way to ensure that we've got a good fit. Now, the other saccharin, Bitrax relies on the person being honest. Yep, I can taste a sweet flavor or smell that's coming in through my respirator. Now, you can fake that. You can say, yeah, nope, I didn't taste it, didn't smell it at all, but that puts you at risk. I like irritant smoke, even though I don't like irritant smoke, just because you can't fake it. It's something that it's going to affect you. Okay? Use of respirators. When you're wearing a respirator, we've got to worry about our seal. So there are things that can interfere with that seal. Facial hair. You need to be clean shaven. Can I have any facial hair? OSHA's interpretation is a mustache to the corner of the mouth is approved. Anything beyond that is not allowed when you're wearing a respirator. Okay. What other things can affect my ability to wear a respirator? If I'm wearing a full face and I put on my glasses, the earpieces on there will affect the seal. So what if I need prescription lenses? Well, you have to have some lenses cut for those. They have inserts that will go inside of the mask. I don't have one of those today, but it will go inside of the mask, and so your lenses are right inside, but they don't have the earpieces. If you have major dental work, maybe you have dentures. If you take those out, that will change the shape of your face. So if you have those, you've got to make sure you're wearing those, or that we're fit tested. A positive pressure. Oh, let's see. Brent says you can't hear me. Can the rest of you hear me? I hope I haven't messed something up. Oh, we can now. All right. I'm getting a little panic there. That's just telling me, hey, you talked too long. Positive pressure fit check. There's an exhalation valve here where the exhaled air comes out. I cover that up and I breathe out. What should happen? The respirator, the mask should puff up just a little bit, and if I can hold that for a second or two, then I've got a positive pressure fit check. All right. Do this every time you put a respirator on. When I'm using the respirator, if I need to take my respirator off, I need to leave the contaminated area. If I need to change filters, if I need to do anything to maintain it, I've got to get out of that contaminated area to do those types of tasks. We need to know how to wash or clean a respirator. Other things, this filtering face piece is a single-use respirator. So when I'm done with it, that doesn't mean as soon as I take it off, you know, if I'm working with some dusty stuff and I go to lunch, I can use the same one again, as long as it hasn't become contaminated or overloaded. But at the end of the shift, I throw this thing away. Okay? And don't leave those hanging around. That's a really easy way to get an OSHA citation, is putting some used respirators hanging around unprotected. If you smell or taste anything, a chemical coming through, you need to get out of the work area and take action. Okay? All right. So maintenance. They need to be sanitary and good working order. That means we need to regularly clean and maintain those things. They should be kept in a sealed container. Plastic bag is generally what we put those in. I use a big Ziploc bag, so then they're sealed. But yeah, those should be kept clean, dry, and in a secure area outside of the contamination. All right. You need to inspect it every time before you use it, particularly if you're sharing respirators, like on an SCBA. So we make sure the components are all in good shape. It's not damaged. The straps aren't cracked or breaking. And if we're using SCBA, make sure we've got better than 90% pressure, so we're not using just a small amount of air and putting yourselves at risk. Our cartridges, we should be able to identify those based on the color or what it says on the label. Use the right one for the type of task that we're doing, and you need to have regular training once a year on respirator use. If something changes in the workplace, we should update people and train them on that. If we know that somebody's messing up, they aren't using their respirator appropriately, then we'll do retraining as well. Each year, we should look at our program and say, how are we doing? Are we messing up, or are our respirator users using it right? Are we using the right respirators for the jobs? Is everybody fit tested? Is everybody medically qualified, et cetera, and evaluate that and then take action. That's part of the OSHA standard, and it's also just good safety business. Records. There's a ton of records that go along with respiratory protection, fit testing, medical qualification, written program, our chains out schedule documentation. There's a lot of stuff that goes on to record these records. That's why you need a program administrator, and why they need to really know what they're doing and get involved. And so with that, you guys thought I was being mean when I initially said one of the goals of this class is to talk you out of using respirators. Now you've been through all this training, you probably say, wow, I really don't want to use respirators. Some of you may still have to fall into compliance with this standard to keep people safe. I realize that we've had an hour to go through a lot of materials, and there may be a lot of questions. If you're going to be the program administrator, that's what we're here for. We'll help you put a program together, but go into this with your eyes open, and if you don't have to wear respirators, don't do it. Eliminate the use of those, and amazingly enough, we'll actually have a safer workplace by not using a respirator. Now, if you need to, if we've got exposures where we're required to do that, or there's a situation where I just have to do this for voluntary use because I've got a guy that his doctor says I have to use this, well, then let's dive in and do it right. And that's one thing that I did jump over was on filtering face pieces. If we voluntarily use a filtering face piece, so that means I'm not overexposed. This is only used for comfort or for medical. The doctor says I need to wear this respirator. We can allow that, but we have to do some documentation for this as well. We have to get the we have to provide the employee with Appendix D of the Respiratory Protection Standard from OSHA, and get them to sign that they've received it. And it basically says that if you don't use this right, it's worse than not using it at all. Okay, man, I covered a lot of stuff there. I'm just looking to see if we have any questions. You guys can go ahead and type those questions into the chat box or the Q&A box. Brent, did I miss anything?
No, I don't think you did. You covered it very well, and it's very good information. Obviously, those that use it, they're there to protect us, so it's up to us to wear it and use it right.
Okay.
Great job.
I'm not seeing any questions. Feel free to give us a call. We will excuse me. We will help out and help the program together should you decide that you need that. And really, at the end of the day, we just want to make sure everybody is safe and kept healthy out on the job. All right. Richard says everybody's all asleep. So questions. Yeah, I wondered that. You know, talk about the type of grade D breathing air. You have to have under 1,000 parts per million of carbon dioxide. At 1,000 parts per million, your body physiologically starts having a reaction to that, and you get sleepy. And so, if you've been sleepy in this class, I think you ought to check the ventilation in your office or in your work area, because you probably got too much carbon dioxide. Because I'm sure the instructor has nothing to do with you being sleepy or this subject matter. So, there you have it. Okay. Thanks, folks. Be safe out there. Have a safe day, and we'll talk to you again real soon.